So problems discussed in this particular Ask Your Doubt series are very important. Those who are preparing for IIT JEE or NEET examination must solve these problems before appearing for the examination, because these questions would really strengthen your subject. So here are two questions of organic chemistry which I received last particular week from the child, and in this particular question it's a single choice question where N-hydroxyaniline is being treated with H positive and you are supposed to tell the product. So I told you number of times that when during the reaction H positive is added, before you give the final product you have to abstract one H positive out of it. So make it a point, that viewpoint always keep in mind. And second question is a more than one choice question, more than one choice where multiple answer could be there. So onto the same framework, the starting material is being put into H positive and you are supposed to tell the reaction intermediate formed during this reaction. So let us do these questions one by one. So first is this particular compound, we call it as aniline, and they have given us N-hydroxyaniline. So one of the H, if I would replace with OH group, so it becomes N-hydroxyaniline as a I just have explained the name of this compound. So N-hydroxyaniline is having a lone pair at two sites and it is being treated with H positive. Now the simple fact here is that where should I attack? Should I attack onto this lone pair or should I attack onto this lone pair? So here the simple viewpoint is that this particular lone pair, if you would just see it carefully, this particular lone pair is in conjugation with the pi bond, or it is in conjugation with it is in resonance with the benzene ring. So definitely during the resonating structure you would found that the electron density on this nitrogen got decreased and it would receive a positive charge because the lone pair went into the ring and it keep on going it like this. So obviously the lone pair present onto the oxygen is more available. So this is the viewpoint. We can simply take it this way, that first H positive would attack onto this, and as also there is a reason also for attacking onto this lone pair is that then you can easily remove out the leaving group as water. So once the lone pair is being attacked by H positive, this oxygen would get a positive charge because one of the electron of the oxygen now is with the H positive. H positives duplet get completed. Now thereafter you have to remove the water. This water would go out, taking out one of the dot electron of the nitrogen. As a consequence, you would receive a positive charge here. Now we generally would say that that particular species would not be that much stable where the electronegative element acquires a positive charge. Now how? There is no way out because you have to bring out the product, because four options are given, you have to answer something. Now here I can do one thing, that if I just would take this pi bond here for the conjugation, because the pi bond is next to the positive charge, so it can undergo conjugation, and as a result this nitrogen's octet can get completed. And now if I would move this bond here, so I would receive a positive charge here. So these two are basically nothing but resonating structures. So the nitrogen's positive charge got stabilized by the fact that there is conjugation available through the benzene ring. Now once this positive charge we have received, now we can attack water onto this point. So if I would attack water here, what shall then I be receiving? So this water now would get a positive charge here, and now I would do the deprotonation. The H positive which we added, I can remove it, and you would get this type of a thing. Now the point here is, one of the option available to you is this also, but this option would not be having aromatic character here. So what I can do here is, which you should notice, there is one hydrogen here. So if I do the intramolecular proton exchange, what does it mean? If I would take this point here, because there is a lone pair still onto the nitrogen, if I would take this H positive from this side to the nitrogen, such that these bonds would move like this. This bond goes here, this goes here, and this goes here. Now as a result of this, what shall I then be receiving? I shall be receiving a moiety of this type. So I shall be getting something of this nature. So as a matter of fact, this is the product being formed during this particular sort of rearrangement, because the H positive has been added, the molecule got rearranged. This got rearranged in an acidic medium to give you para-hydroxyaniline. Another question which they have asked is on to the same viewpoint, on a similar viewpoint. So this is the starting material which is being given. Again, you have to take a call where the H positive would attack, either on this or on this. So I shall not be attacking onto this oxygen's lone pair because it is in conjugation with pi bond. So the availability of lone pair would be lesser. So I definitely would be attacking on the similar viewpoint onto the lone pair available onto the nitrogen. So as a consequence, this would get a positive charge. Same viewpoint we can now again would take this ammonia out of the system. This ammonia goes out. As a result, this oxygen would carry a positive charge, which is not very stable, but this resonance would make it stable, and you can bring it like this. So as a consequence, this oxygen, and here you would get a positive charge. Now what we can further do here is that same ammonia as a entity would attack onto this positive charge. As a consequence, here you have this nitrogen would get a positive charge and this would remain as such. So I think you are getting my point. Now lastly, what I can do is I just would take out one of the H positive of the ammonia, and as a result, this type of a species is being generated. But this would not be having a aromatic character, so we simply would take out this H positive. This bond goes here, this goes here, this goes here. Similarly, just like in the previous case, here also we just happen to receive the same entity as the final product. So what basically are the intermediate formed during this particular reaction? That is what they are asking us. So one intermediate you have received this one. This is one of the intermediate. Another intermediate can be this one. Another can be this one. Oh, this is the same one as the first one. Or it is just these two are nothing but resonating structure. So one of the intermediate is this one. So let us see what options they have given us to us. So what are the options available in this particular question? So in this particular question, we happen to get this is also being formed. This is the first point. This is the first attack has happened onto this one. Then this ammonia went out and to give you this one. And this also has been received. This also has been received. And as a matter of fact, we happen to get this one also as the second last intermediate during this reaction. This is this one. This is referring to this one. Okay, so I hope you have understood it. All the four intermediate which they have shown are the part of this particular reaction sequence. So answer to this question then shall be A, B, C, D is the answer for this question. And for the previous question, I haven't marked the answer. So in the previous question, this had been the answer to the previous question. So C option is the answer. So I hope you have enjoyed this particular discussion. And as a matter of fact, what we have, let me consolidate what we have said. The lone pair did not attack the heteroatom which is next to the benzene ring. It has attacked the corner atoms and happened to get the same product. As a matter of fact, you should always remember this is Bamberger rearrangement. Although this is not the part of the syllabi as the name of the reaction, but you should mark this in your knowledge bank that this is Bamberger rearrangement. Thanks a lot. Have a nice day. We will meet you in some other video. Thanks a lot. Take care.